Good afternoon, everyone. Am I audible to you, everyone? Okay, Deepak, Vikas. Thank you. Okay, in the inverse Laplace transform, we learn the basic formulas. Thank you, everyone. As well as we learned the first shifting theorem of the inverse Laplace transform, then division by S property, right? And in today's morning session, we learn the differentiation of the inverse Laplace transform. Okay. Now today we learn in this session second shifting theorem for the inverse Laplace transform. Okay. Everyone, please note it down in your lecture notebook. The second shifting theorem of the inverse Laplace transform. One minute. Screen is visible clearly, everyone. You can also, if you attend the session using your mobile, then you can also zoom this screen, right? Second shifting theorem for inverse Laplace transform. Yes, Raj Kishore, wait a minute. If we know that Laplace inverse Fs is equal to f of t, then Laplace inverse e raised to minus as Fs is equal to f of t minus a into u of t minus a. If you remember in the Laplace transform, when we learned this second shifting theorem, then we define the unit step function also, and the another name of the unit step function is Heaviside unit step function. That's why we can also write that is equals f of u t minus a into h of t minus a. H stands for the Heavisides and U stands for the unit step function. Okay, everyone, quickly note it down. Laplace inverse Fs equal to Ft and Laplace inverse e raised to minus as Fs is equal to f of t minus a into u of t minus a. U stands for the unit step function and H stands for the Heavisides function. Okay, quickly note it down. Then today we learn the problems based on the second shifting theorem, and as well as at last we discuss the MCQs. Yes, Raj Shakaria, quickly note it down. and please join in time in the session. Now the problems based on the second shifting theorem. Students, as we know that in the previous property, I told to you when the questions regarding for the inverse Laplace transform, that is regarding to the logarithmic, tan inverse and cot inverse, then you have to apply the particular property of the differentiation for the inverse Laplace transform. Same thing. When in the inverse Laplace transform, the term e power minus s, this is the indication. This is the indication. The question is regarding to the second shifting theorem, right? Because in the question, not mentioned that you have to apply here which particular property. You have to identify first, and then after you have to solve the particular question. Okay. Therefore, please remember when we solve all the question, then one particular term present in your question, please remember this term, and using this term you can identify the question. This question is regarding which term. Okay. Now the examples. The first question. Find inverse Laplace transform of e power minus as divided by s. Now this is the indication e power minus s. This question is regarding to the second shifting theorem. Okay. Now solution of this question. Here, first you have to identify the term without e raised to minus s. Right? This is one. Here f of s is equal to 1 by s. Okay. Now apply inverse Laplace transform both sides. Apply inverse Laplace transform both sides. Therefore, Laplace inverse f of s is equal to Laplace inverse 1 by s. Okay, we apply both the sides Laplace inverse. Now, right hand side, this is 1, right? Laplace inverse fs equal to, we are getting 1. Now, by second shifting theorem, Laplace inverse e raised to minus as, when this term is multiplied with the f of s, then what is the change on to the right hand side? If this function, this is our ft, right? In place of ft, we have to write f of t minus a. But this is the constant term, therefore remains as it is, and u of t minus a, right? We get it the value of the a from here, right? But here a is a. If in place of a 2, 3, 4, omega, alpha, any term, then you have to apply in place of a this term. Okay, therefore the answer is u of t minus a. This is the answer for this first question. I again repeat this question. Find the inverse Laplace transform of e power minus as by s. How can we solve this question? First, you have to identify the f of s, right? And this f of s is without this term, right? We again see the property one time. E raised to minus is f of s, right? Therefore, first you have to identify f of s. That's why we are getting ft. And then after this f of s is multiplied with e power minus as, then what is the change into the answer? In place of f of t, you have to write f of t minus a and multiply with the unit step function u of t minus a, or you can also write it h of t minus a. Everyone clear? Any doubt regarding this? Okay, the same thing we apply in this first problem. First, we identify f of s. Therefore, we are getting f of t. Now, this f of s is multiplied with e raised to minus a s by using the second shifting theorem. And this is f of t is the constant, therefore no change, that remains as it is, and multiply with the unit step function. Everyone clear? Then quickly write yes into the chat box. Any doubt? Then you can raise your hand. Okay, Deepak. Now the second question. Example number 2. Find inverse Laplace transform of e raised to minus 2s divided by s minus 4. Okay, now tell me what is the fs here? Here, f of s is equals 1 by s minus 4. Okay. Now apply inverse Laplace transform. Now first we have to find ft, right? Apply inverse Laplace transform. Therefore, Laplace inverse fs is equal to 1 by s minus 4. Okay, everyone write the answer. What is the answer for Laplace inverse 1 upon s minus 4? Quickly write into the chat box, everyone. Laplace inverse 1 upon s minus 4. Yes, Kanavi. Yes, Kunal, Vikas, Deepak. Deepak, the power is the positive, not negative, because here s minus 4. Right? Therefore, the answer is e power 4t, and this is our ft. What is the value of a here? Here a is a 2, right? By second shifting theorem, Laplace inverse e power minus 2s divided by s minus 4. Therefore, f of t minus 2, because a is a 2, and u of t minus 4. Therefore, e power 4 in place of t minus 2, and multiply with u of t minus 2. This is our answer. Clear, everyone? Note it down this question. Yes, Vikas, 1 minute. Yes, Vikas, you can unmute yourself. Vikas.
Yes, ma'am. Yes, ma'am.
Yes, what is your question?
मैम मैम प्रीवियस क्वेश्चन में e रेज टू माइनस एस है तो उसमें a को a का यूज नहीं हुआ है.
Yes, because A is a
H उसमें होना है.
Listen. A कहाँ है यहाँ पे? A की वैल्यू A ही है. तो यहाँ पे u of t माइनस है, ठीक है. और ये कांस्टेंट टर्म है, तो कांस्टेंट टर्म में हम कुछ चेंज नहीं कर सकते. इस क्वेश्चन में क्या है? A की जगह पे क्या है विकास? 2, राइट? इन प्लेस ऑफ A is 2. Therefore t minus A, but A is 2 is here. Therefore t minus 2, u of t minus 2. Yes. Yes, Vikas.
Okay. Okay, ma'am.
Done?
Okay.
Okay. The third question. Find inverse Laplace transform of e power minus 2s divided by s plus 4 whole cube. Okay. Here f of s is equals 1 by s plus 4 whole cube. Now quickly find this inverse Laplace transform and write your answer into the chat box. Apply inverse Laplace transform. Therefore, Laplace inverse Fs is equal to Laplace inverse 1 upon s plus 4 whole cube. Now here in place of s plus 4, what is the answer of this inverse Laplace? Yes, Raj Kishore. Yes, Karnavi, very good. Yes, Karnavi, unmute yourself.
Yes, ma'am.
Yes, Karnavi, how can we solve
Yes,
this
ma'am.
inverse Laplace?
Ma'am, first shifting theorem.
Yes, s plus 4, therefore e raised to minus
Raised to
4t.
minus 40.
Then the remaining is 1 by s cube. And 1 by s cube, the power is the integer. Therefore, t raised to n minus 1 by n minus 1 factorial. Right? This is our f of t. This is our f of t. Clear up to this step, everyone? Now we have to apply the second shifting theorem. Okay, Vikas, 9 number, unmute yourself. 9 number, Vikas.
Yes, ma'am.
Okay. Now, please wait for 1 minute. Okay. Here, Laplace inverse f of s, we are getting e raised to minus 4t t square by 2. This is our ft. Okay, Vikas? Now, by second shifting theorem, Laplace inverse e raised to minus 2s, multiply this, divide by s plus 4 whole cube. Now, because what is the value of a here? Because what is the value of a?
Ma'am, एक two
Yes, 2.
two.
Yes, 2. Therefore, f of t minus 2, u of t minus 2. Okay. Now, this is our function. In place
Yes.
of this t and this t, we have to change this. Therefore, e raised to minus 4, t minus 2, t minus 2 whole square divide by 2. This is our answer. Now, Vikas, clear your doubt?
Yes, ma'am.
Okay, this is the answer. Now you can mute your mic. No. Everyone, please note it down. This is the previous slide of this question. In this slide, we find the f of t, and the next slide, we apply the second shifting theorem. Okay. Done, everyone? Now the next question. Find inverse Laplace transform of s e power minus pi by 2 s divided by s square plus 4. Now this term is our f of s. Okay. Now find the f of t quickly, everyone, yourself, and write your answer into the chat box. Here, fs is equals s by s square plus 4. Apply. Quickly write your answer. I'm waiting for your answer. What is the f of t value when we apply inverse Laplace? Apply inverse Laplace transform both sides. Yes, Deepak, very good. Laplace, yes, Pranavi, Nitish. What about the other students? Trilok, Kumarji, Apurva, Pavan. Yes, Nitesh, 1 minute. Yes, Roshan, very good. But here, what is the value of the K, Roshan? This is the applied maths, right? Therefore, apply the value of the, yes, 2 square. And this is the cos 2t. This is our ft. Now by second shifting theorem. Therefore, Laplace inverse e power minus pi by 2s into s divided by, s square plus 4. Therefore, this is our ft. Therefore, f of t minus a value is pi by 2. T minus pi by 2, u of t minus pi by 2. Now we change over here in the next slide. Please note it down these things. Therefore, Laplace inverse e raised to minus pi by 2s into s divided by s square plus 4 is equal to cos 2t. Therefore, cos 2t minus pi by 2 into u of t minus pi by 2. This is the answer, but pi by 2 is the known angle. Therefore, here required more simplified steps. Cos, this 2 multiply inside. Therefore, 2t minus pi by 2 into 2, 2 to cancel. Therefore, u of t minus 2. As we know that cos is an even function. Cos is an even function. Therefore, cos of minus theta equal to cos theta. Therefore, we change this term into the bracket. 2t minus pi, we can also write pi minus 2t. No change in u of t minus pi by 2. Okay. Now, cos pi minus 2t, yes. Therefore, this represent which quadrant? Cos pi minus 2t. Yes. Yes, Rishi, very good. Pranavi, very good. Pi is here. Therefore, pi minus theta is represent this quadrant. Right? And in this quadrant, only sine and cosec are positive. Cos is the negative. Therefore, minus cos 2t u of t minus pi by 2. Therefore, when your angle value, right, is given into the radian formation, right? Therefore, more simplified steps, you have to do it into the answer. Now, quickly note it down. I am again repeat, this is also answer, but here the a value into the radian, therefore 2 multiply inside, right? Then use the funda. This is cos is a even function, therefore cos of minus theta is the cos theta. Then after using the quadrant knowledge, right, cos of pi minus theta that represent the second quadrant, and in the second quadrant cos is the negative. Therefore, minus cos 2t u of t minus pi by 2. That is our answer. Quickly note it down, all the things. Now the next question. Find inverse Laplace transform of e power minus 3s divided by s square plus e dash plus 25. Okay. Here f of s is equals 1 by s square plus 8s plus 25. This is the question of the first shifting of the polynomial. Therefore, you have to find the correct last term. Tell me what is the correct last term? Correct last term value is quickly. Yes, Karna. 25 divide into the two parts. Yes. No, Vikas, not it's a 5 square. Yes, Kinjal, good. 16 and 9, right? Therefore, f of s is equals 1 by s square plus 8s. We convert into the perfect square. Therefore, the last term is 16 and plus 9 is remaining. Therefore, we can write into s plus 4 whole square plus 3 square. Now, inverse Laplace transform both the sides. Therefore, Laplace inverse 1 upon s plus 4 whole square plus 3 square. What is the inverse Laplace transform of this term? Everyone try this. We solve many problems on this methods. Yes, Karnavi. What about the others? Kunal, Rishi, Deepak, Apurva, Amit, Kinjal, Priyanka, Saurav, Zayed Alam, Pavan, Raj, Govind Kumar ji, Sonu Kumar. Yes, Ajit Kumar, Ayub, Kevin. Yes, everyone. Write your answer. Yes, Vikas. Kinjal, very good. Here s plus 4, therefore e raised to minus 4t. Then remaining is 1 upon s square plus 3 square, therefore 1 by 3 sine 3t. Okay. This is our f of t. Now, Laplace inverse fs is equal to, we are getting e raised to minus 4t sine 3t. This is our f of t. Now, by second shifting theorem, right? By second shifting theorem, Laplace inverse e power minus 3s divided by s square plus 8s plus 25. What is the value of a? 3. Therefore, f of t minus 3, u of t minus 3. Now, 1 by 3 as it is, e raised to minus 4 in place of t minus 3, sine 3 in place of t minus 3, and u of t minus 3. Okay, now this 3 is multiplied inside. Therefore, 1 by 3 e power minus 4t minus 3 sine 3t minus 9 u of t minus 3. Right? This is the answer of this question. Okay, everyone? Quickly note it down. Okay, quickly note it down this question, everyone. Now one more question. First shifting and second shifting together, right? Next question. Find inverse Laplace transform of s e raised to minus 2s divide by s square plus 2s plus 2. Here, f of s is equals s by s square plus 2s plus 2. Right? Therefore, we change this. What is the last term? We know that 1. Therefore, 1 and 1. Converting into the perfect square. 2s plus 1 plus 1. And therefore, we need into the numerator also plus 1. Therefore, we are here adding plus 1 and subtracting plus 1. Therefore, s plus 1 minus 1 divided by s plus 1 whole square plus 1 square. Now we apply the Laplace inverse. Everyone clear? First we convert the denominator into the perfect square. Now this is s plus 1 whole square. Now we have to apply the first shifting theorem. Therefore we need in place of s plus 1 into the numerator also. Therefore adding plus 1 and subtracting plus 1. Okay. Now apply inverse Laplace transform. Apply inverse Laplace transform both sides. Therefore, Laplace inverse f of s is equal to Laplace inverse s plus 1 minus 1 divided by s plus 1 whole square plus 1 square. Therefore, e raised to minus t, Laplace inverse, remaining term is s minus 1, s square plus 1. Therefore, separate denominator minus Laplace inverse yes Kanav, e raised to minus t, this is the cos t minus sin t. This is our f of t. Now note it down this and then after apply the second shifting theorem. Okay, now apply the second shifting theorem by second shifting theorem. Laplace inverse e raised to minus 2s s by s square plus 2s plus 2. Therefore, a is 2. Therefore, f of t minus 2 into u of t minus 2. E raised to minus t minus 2 into the bracket cos t minus 2 minus sine t minus 2 into u of t minus 2. This is our final answer. Okay. Now, two questions for the practice. You can do it yourself. Laplace inverse e raised to minus pi s divide by s square minus 2s minus 2. Yeah, plus 2. Yes. And answer of this question, e raised to t minus pi sine t minus pi u of t minus pi. And the second question, Laplace inverse e raised to minus s 1 plus root s divide by s power 3. Answer of this question, f of t you are getting t square by 2 plus 4t power 3 by 2 divide by 3 root pi. And then apply second shifting theorem, f of t minus 1 u of t minus 1. Right? Laplace inverse e raised to minus s fs. Okay. Okay, everyone, please do this first question yourself. Okay, now the first MCQ. Check the differential equation is exact or x square minus x minus y square dx minus 2xy dy equal to 0. Options xz, b known xz. Can't decide. Everyone check that this is exact or non-exact. Which answer is correct? And the second question, yes, very good. And the second question, and also write, if this is exact, right? Then also write the value of the del m by del y and del n by del x. If this is exact, then write the value of the partial differentiation in the chat box. What is the integrating factor? Yes, Kinjal, Rishi. Remaining student, write your answer. dy by dx plus 2y tan x equal to sin x. Sec x, sec square x cos square x and d minus sec square x. This is exact. Yes, I'm writing over here del m by del y. This is minus 2y and del n by del x. This is also minus 2y, implies exact. Therefore, exact. What is the integrating factor? Quickly find the integrating factor. Yes, Rishi, Kinjal, very good. Everyone quickly find the integrating factor. dy by dx plus 2y tan x equal to sin x. Okay. IF equal to e raised to integration p dx. Use this formula, everyone. E raised to integration p dx. And what is p here? That is integration tan x. Find this. Yes, the answer is B, sec square x, right? E raised to integration 2 tan x dx. Tan integration is a log mod sec, therefore e raised to 2 log sec x Then apply the power, and E and log is the cancel out. Therefore, answer is sec square x. Quickly note down these two MCQs. Okay, thank you very much, everyone. Have a good day. Now you can leave this meeting.